Hello, algebra students. We're going to continue our methods for solving quadratic equations. Last time we covered the square root property, which is really a nice way of solving quadratic equations if you're given a certain format. You have a quantity squared equals a number, and then all you have to do with this setup is take your quantity with x on one side, your number on the other side, and square root both sides and solve for x. So it's a real nice method to solve quadratic equations. So solving by square root property if it's set up that way. So today we're going to look at solving quadratic equations via completing the square technique, which is a real good technique that you could apply to other sorts of situations. You apply that sort of math method in other scenarios. This is a little bit of a harder approach, and the idea with completing the squares we'll get to is to try to make it into this format. So our main goal, for completing the square, we want to keep this in mind, is to manipulate our quadratic. You want to take your quadratic equation to make it into something called a perfect trinomial square. Okay, a perfect trinomial square, i.e., in the format, if you don't remember what a perfect trinomial square it is, we'll cover that so that you can understand it's a particular type of quadratic equation in that the factors are exactly the same. So i.e., in the form where the factors are exactly the same. Okay, so we want to manipulate a quadratic equation to make it into a perfect trinomial square, and it's going to be in the form where the factors are exactly the same. So some examples. Here's an example of a perfect trinomial. Okay, and a perfect trinomial, this example is going to yield certain factors if we were to factor it out. So if we had x squared plus 6x plus 9, this is considered to be a perfect trinomial square since the factors are x plus 3 times x plus 3, which can be written as x plus 3 quantity squared. Okay? So we're going to get equations, and we want to make them into a quadratic where the factors are exactly the same. So the idea is by making into a perfect trinomial square. And the idea is we're going to make them into this sort of format if they're not already in this format where the factors are exactly the same, by making into a perfect trinomial square if not already. And the way we're going to do that is by completing the square, which is the technique we use to make them in that format. So by making them into a perfect trinomial square, by completing the square, what we do then is, we can just take the square root of both sides to solve. Then we could just use the square root property. Okay? So some key words here is square root property is when we have a quantity squared equal to a number, and then we could just take the square root of both sides. So ultimately we want to manipulate our quadratic equation to be in this format. So this is what we want. This format. Okay. And this format is what we want to do is we want this trinomial square. So we're going to manipulate to get our trinomial square so that the factors are exactly the same, and gives us something like this. And the way we do that, we complete the square so that we could take the square root of both sides and solve. So very important idea, and I'll kind of put some examples up to do as we go along, but some extra little details here, or some important foundational details to put up before we move on. There's a lot of wording to use, but as long as you get the idea of what we're after, I think you'll understand this method a little better. Okay, so what we're going to do is to say in general, the perfect trinomial square format is going to be, and we're going to use letters here, is going to be if I have two exact same factors where A is some real number with an X or a variable, and B is some real number. If I multiply this out, I'll get some sort of quadratic out of it, but I'll get a specific quadratic in which the first term will be this first term squared, and the last term will be this b squared. And if it's a perfect trinomial square, there's a really neat pattern to it. If I take whatever a is times whatever b is, the two terms in your binomial, they'll be in the middle, but they will be doubled. So if I say plus 2ab plus b squared. So this is a typical perfect trinomial square, quadratic, in which you could factor it and get exact same factors. So again, a is the first term of your binomial, b is the second term of your binomial, and when you multiply that out, you get this pattern. Now, because it has a certain pattern to it, there's a few tricks we can do to make quadratics perfect trinomial squares if they're not already. So this is their format, and this format allows us to manipulate certain quadratic equations. So an example, again, just to solidify this, if I had something like x squared plus 4x, let's see, plus 4. This is the same thing as x plus 2 quantity squared. This would be your a, this would be your b, this would be a squared, this would be a times b doubled, Okay, 2 times x times 2 is 4x, and this would be your b squared. That's an example. Here is my factors that are exactly the same, and they multiply out to this quadratic. So that's an example of another perfect trinomial square. And what we want to do is we want to look at problems when it's not necessarily perfectly done out for you. So what happens when we have quadratics that are not in this format? So to solve, something like we did previously, x squared plus 6x plus 9 equals 0, we know that this factors, and here, if you recognize it's a perfect trinomial square, you could just go ahead and write it as this, and take the square root of both sides. You get x equals -3 in that case. Okay? So if we were to solve something like that, that's how you'd approach the answer. Okay, to solve this, we could apply the square root property. We'd factor and take the square root. So now the next question is, how to solve such as, let's say I had x squared plus 6x minus 7 equal to 0. Okay, I'm changing a few things. If you looked at this, you would say, well, there's no way I could factor this into pieces in which the factors will be exactly the same. So if you were to factor this, you would have x minus 7, x minus 1. You would try different combinations, but it wouldn't work, right? There's no way it's a perfect trinomial square. If you notice, it doesn't fit this pattern. Okay? So if a is x and b is the square root of 7, 2 times that does not yield the 6 in the middle there. So what we'd have to do here is we'd have to apply our technique of completing the square. So how do we solve a quadratic this way? Well, we can complete the square to make into a trinomial. Okay, that's what we're going to do. We're going to manipulate this. So let's look at completing the square technique. How do we do that? Okay. So the main key is to complete the square. You're going to have a certain technique. So again, if you have your quadratic form, ax squared plus bx plus c equals 0. This is your standard form or your general format for quadratic equations. And to complete the square, number 1, you take half of b, your middle term, and then 2, you're going to take that half of b and you're going to square it, and you're going to add this number to both sides to complete the square. Okay, so this is what you do to complete the square. So it seems really simple, but there's a few things that we have to move around to be able to do this. So here, let's do an example. I'm going to give myself a little more room. example. And we're going to solve by completing the square. Okay. So we have x squared plus 6x minus 7 equals 0. So here we're going to attempt to solve this using this method. And typically I say if you're asked to solve quadratics, you usually would just want to try to factor it, use the square root property, or something we're going to come up to next, which is using the quadratic equation. So I would not do completing the square unless I was doing some sort of fancy graphing I want to apply it to a graph or some other application I was looking for, because typically this is a little tedious to do. However, it's a good technique to know. So we're going to do this, and there's a few tricks involved. Number one, what we're going to do is you say, okay, what I want to do is reformat this. And I'm going to go ahead and take my x squared. Now this is much brighter. I should have been using this all along. My apologies. So hopefully you're seeing this okay. I'm going to reformat this. So I'm going to bring my ax squared and my bx term here. And I'm going to leave a little space here. And I'm going to bring this minus 7 over, so I have this equal to 7 here. Okay. And the reason I do that is because I know this is not a perfect trinomial square, and there's no way I'll get exactly the same factors. So what I have to do is I have to figure out what number I need to add here in order to complete the square. So what number to add to complete the square. So what I do is I figure out, I take, number one, I take half of my b term. So I'm going to take half of positive 6, the coefficient here, and I get positive 3. And my next step is to take that positive 3 and square it, so that I get 9. This is the number I want to add here. Okay. So my next step, just to see how I jump here from this step to the next, I want to go ahead and add 9 to both sides in order to complete the square. So I want to add 9 here to complete the square, but as we know, whatever you add on one side, you must do to the other side to keep the equality. So x squared plus 6x plus 9 equals 7 plus 9. Okay. Same equivalent equation, but now I have this formatted so that I can now go ahead and say, oh, this is a perfect trinomial square, and when I factor this, this becomes x plus 3x plus 3. So concisely, that is x plus 3 quantity squared equals 16. And now you can apply your square root property. All right, so now you can apply the square root property. So what I'm going to do next is x plus 3 quantity squared equals 16. I'm going to go ahead and take the square root on this side, the square root on this side. And then I get x plus 3 equals plus or minus 4. And then I go ahead and bring that 3 over so that I get x equals minus 3 plus or minus 4. And this gives me two solutions, which are x equals minus 3 plus 4 and x equals minus 3 minus 4. So I get x equals 1 and x equals -7. Okay, so I have solved this by completing the square. And there's many other tricks here. So this is the technique. This is half of b. So note that this coefficient is 1 right here. Sometimes what you have to do is factor out any excess coefficients you have there. There's some tricks here you have to be careful of. Okay? But when you have just a 1x squared, this is fairly simple. This works out really well. Okay, there are some trickier problems on the horizon. Let's go ahead and practice a few more of these to get this down first. Let's do another example. Let's do example 2 here. And again, we're solving by completing the square. So let's do x squared minus 10x plus 3 equals 12. Okay, so maybe I was looking at this and thinking, well, maybe I could just solve it by factoring it away. Maybe it is already a perfect trinomial square. I'm going to do some rearranging to put it into quadratic form. So this is the same as x squared minus 10x. Subtract the 12 there from both sides. So I have minus 9 equals 0. And you want to look at this and say, can I factor this so that the factors are exactly the same? Or do I see the perfect trinomial square pattern here? Meaning, is this double the root of this and this? So the square root of x is x squared is x, the square root of 9 is 3. So 3 times x doubled is 6x, whereas I have minus 10 in the middle. So I know this is not a perfect trinomial square. So it's not a perfect trinomial square. So not a perfect trinomial square. What you want to do then, complete the square. So that's what we're going to do. So these are the processes that you want to go through when you're solving something like this. Okay, so not a perfect trinomial square. Let us solve it by completing the square. So we're going to reformat this so that we have x squared minus 10x equals 9. And bring that 9 over. And now the next step is to figure out what I need to add here to make this a perfect trinomial square so that I can square root it. So, what number to add? I'm going to condense my steps here, my thoughts a little more. So here we'll do, step 1 is to take 1/2 of the minus 10, which gives me minus 5. My second step is to take that negative 5 and square it so I get 25. So I am going to add the magic number of 25 to both sides. And that will complete the square. So here, moving along on this side, now what we're going to do is, going over here, we are now going to add 25 to both sides. So we have x squared minus 10x plus 25 equals 9 plus 25. Okay, so we now have x squared minus 10x plus 25 equals 36. And if you notice, this is a perfect trinomial square, and I could factor this to 2 exact same factors, so it becomes x minus 5 quantity squared. This part of your binomial your b term is always the same as what you take half of here. Okay, so here's your b term. So, and you could double check. You could, if you multiply x minus 5 times x minus 5, you always should be able to recreate the original trinomial. Now that's equal to 36. So now I could take the square root of both sides. And I take the square root of 36. And I get x minus 5 equals plus or minus 6. And then x equals 5 plus or minus 6. So x will be 5 plus 6, which is 11. And x will be 5 minus 6, which would be minus 1. So what we have here is x equals 11 and x equals minus 1. Okay, those are my solutions. Great. Okay, many more to come. So, what happens when you have coefficients that are not 1? Let's go ahead and do another example here, and then we'll leave the rest to you to practice. Some problems will get trickier than others. But again, this is not a method that you typically use to solve quadratics. You usually apply it to other math principles. Okay, so here I'm going to put some real messy ones here. What if I had something like this? Kind of changed my original problem, so we're going to work through this and see how it goes. Now the problem here is I have a coefficient of 2. So we're going to have to do a few little tricks here to complete the square. So I'm going to solve this by completing the square, but first thing off, I'm going to go ahead and reformat this. I can see that I can't factor this to make the exact same factors. In this case, I have a little bit of a problem because this is, I want to factor out my 2 here. I don't want to find the combination when I don't have a coefficient that's different than 1. So what I'm going to do is I'm going to factor the 2, and I'm going to complete the square with what's left inside when it's cleaned up a little bit. So here, this part I want to complete the square with the reduced quadratic here when this is a 1. So that's something that you have to remember. If you have a coefficient that's not 1, you have to factor it out. So we know that these are equivalent. On the other side, well, that just doesn't matter. I don't need to worry about that minus 7. Okay, I don't need to factor that out. That just kind of will play a role a little later when I'm adding, when I'm taking the square root, applying the square root property. So now the next step here on this one would be to, I gave you a bit of a doozy here because we're going to have some fractions involved, which happen. Now I want to find out what I need to add here in order to complete the square. So what number to add? Well, here I have to take half of the 5, so number 1. Take half of your plus 5, which is going to be a messy fraction, 5 halves. Then number 2, we're going to take that 5 halves and we're going to square it to make more of a mess. And we'll have 25 over 4. However, that is the combination that will make a perfect binomial square. Now I'm going to add 25 over 4 here. And you may think, well, I'm just going to add 25 over 4 here, but no, not at all. This 25 over 4 is actually doubled because it's on the inside of the parentheses. So you have to apply the double value to it. So I'm really adding 2 times 25 over 4. So I have to add 2 times over 25 over 4 on this side. So a little trick here. So these are attached. So what I've really done here is I'm going to add double 25 over 4 on both sides. Okay, so rewriting this, we get 2 times x squared plus 5x plus 25 over 4 on the inside equals minus 7 plus 2 times 25 over 4 on the end. Okay, so what is the factors here? Well, I'm going to make it a little simple. It's always half of what your middle term was. You could double check that, but it's x plus 5/2 quantity squared. Okay, so if you say x plus 5/2 times x plus 5/2, it multiplies out to this quadratic, and this will equal negative 7 plus 2 times 25 over 4. So I'm going to do some side work here. Let's see, so negative 7 plus 25 over 2. This reduces to negative 14 over 2 plus 25 over 2, and that gives you 11 over 2. That's a bit of a messy number, 11 over 2. Wow, what a problem. So you have 11 over 2. Okay, when you work out the fractions. And now we're going to come back all the way over here because we have limited board space. And we are going to leave that last step here. Thing with video, you could just rewind, unlike events in real time. So now we have 2 times x plus 5/2 squared equals 11 over 2. And what happens here is we almost have what we want here. We're just about ready to take the square root of both sides, but what I'm going to do is also make it a little simpler first. I'm going to divide out this 2. So I divide this side, I divide that side, and I end up with x plus 5/2 quantity squared equals 11/2 divided by 2 or multiplied by 1/2 is 11/4. So this becomes 11 over 4. And I'm just about ready now to take the square root. Looks good so far? Checking work? Yes? All right, let's take the square root of both sides. And voila. We have x plus 5/2 equals plus or minus. The square root of 11 over 4 is the same thing as the square root of 11 over the square root of 4. And if we break this down further, we get x equals negative 5/2 plus or minus the square root of 11 over 11, the square root of 11/2, or the square root of 11 over 2. That's a tongue twister. For me it was. Okay, and the very last step is these could be all put over the same denominator because they're exactly the same. And I can concisely write my answer as -5 plus or minus the square root of 11 all over 2. And I can approximate that if I like. Messy answer, lots of steps, but a lot of practice of all the techniques you've learned so far. So a problem like that hopefully helped you to understand completing the square a little bit better. I would go ahead and practice more of these. Once you get familiar with the technique, you can see how it applies in a lot of different situations. So again, I'll say there are 4 methods for solving quadratics. So if you remember solving quadratic equations, the first way is first solve by factoring. That's always the easiest if you can. Number 2 would be to solve via the square root property. If you can. All right. Number 3, if you can, meaning if the format is set up. Number 3, I like to say, solve by completing the square when it's asked of you on an exam or quiz. So solve by completing the square. I'll say when you're asked to do so. That's my tip. Okay, number 4, our next mode we're going to get into is solve by the quadratic formula. And I'm going to say when you are asked to do so. Sorry, that's completing the square. The next is to solve by quadratic formula, and that I always say is when you can't factor. Okay. So we just covered this, completing the square. And what I typically like to say is do this. This is the most important. Solve by factoring. Okay? And if you can't factor, I say go to the quadratic formula, which is typically how you'd solve any sort of application problem when a quadratic equation comes up. Now, in certain circumstances, you'll come up with one that's in a format where you just take the square root, and that's the easiest to solve. So what we'll do is we'll do this next, and we'll complete our series on solving quadratic equations, and then get into graphing quadratic functions. All right, hope this helps, and until next time.